press the bell icon on the YouTube app and never miss another update.
Hello students, in the last class we discussed about the properties of colloids that is nothing but what we can say, the Tyndall effect and then the charge of the colloid and Brownian moment. Along with that we discussed about the color of the colloid and also very important concept, that is nothing but the charge of the colloid. And we also done with the experiment which helps to know the charge of a colloid, right? So that is called as the electrophoresis. That process or that method, but what we are going to use to find out the charge of an colloid is called as the electrophoresis, where we can see the movement of the what we can say colloidal particles towards opposite electrodes depending upon their charge. If they are deposited on the cathode, we can say that the colloid is positively charged because cathode is negative, right? So similarly, if they are deposited on the anode, we can say that the colloid is negatively charged. Like that we can find out the charge of the colloid, right? And also we done with very important concept that is called as the preferential adsorption of ions. That is one of the major cause for the charge of the colloid. How there is a formation of an electrical double layer and what is that potential difference or zeta potential, right? So now with that let us move on to the one more and last property of the colloids, that is called as precipitation. Precipitation, or we can say that one as coagulation, or we can call that one as also as what is that, flocculation. Any of the value we can name we can use for that one. That is the next property of the colloids, right? So what is this precipitation? As you all know that the lyophobic sols are highly unstable, whereas if you take the lyophilic sols, they are highly stable. Why the lyophilic sols are stable? You know the reason for that one also. So you know that lyophilic sols are stable and they do not possess any charge. They are not do not have charge. They don't have charge, right? Because of their high degree of solvation. Because of their high degree of solvation, they are highly stable and they will not possess any charge. But if you take lyophobic sols, no? If you take lyophobic sols, they are highly unstable. Right? So lyophobic sols are highly unstable and the charge. So for the R, it is due to the presence of charge. It is mainly because of their charge. They are highly unstable, right? Or we can say that the stability of the lyophobic sols mainly depends on what? The charge. So if you remove the charge of these colloids, no, so that is nothing but lyophobic sols. If we remove the sols, that is the charge of these colloidal particles, or you can say the colloids, so we are going to see that the particles settle down. That leads to what? Precipitation of colloids, or we can say that is called as what? Coagulation or flocculation of colloids. So the charge of lyophobic sols is mainly because of, or you can say the stability of lyophobic sols is mainly because of the charge. They are unstable, but if their stability they are having means it is mainly because of their charge. So if you remove the charge by some method, so what happens? If there is charge means then only they will be moving because of repulsion between the similar charges, right? So they will moving in case of a what we can say, they will move in the colloidal solution in a Brownian moment, or you can say a zigzag fashion. They will be in a continuous state of motion. But if you remove the charge by some method, what happens? So the charge will goes on, they will settle it, they will get discharged and they will get settled down. So what we call that one as precipitation, right? So then we can define this precipitation process as the process of, right, it is the process of settling down of colloids by the addition of some reagents. That is the process of settling of colloidal particles by suitable methods. That the like that we can define this one. So what is that? The process of settling down of, yes, colloidal particles by using suitable methods, okay, because there are so many methods, that's why. So it's called as, suitable method is called what? In one word I am going to use coagulation, or you can say precipitation of the colloids. It's called coagulation. The colloidal particle should be settled down, then only we are going to get a precipitate, then only we are going to get a coagulate. That will happen only when we remove the charge. So that we can do by addition of some of the reagents or by using suitable methods. So let us discuss what are those different methods that we can employ for what? The coagulation, or you can say the precipitation of the colloids, right? So ಏನೆಲ್ಲ ಮೆಥಡ್ಸ್ ಇಂದ ನಾವು ಏನು ಮಾಡಬಹುದು ಅಂದ್ರೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಮಾಡಬಹುದು ಅಥವಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನು ಏನು ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ ಕೋಆಗುಲೇಟ್ ಮಾಡಬಹುದು, ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಅನ್ನು ಕೋಆಗುಲೇಟ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ. ಸೊ ಅದರಲ್ಲಿ ಬರುವಂತದ್ದು ದ ಫಸ್ಟ್ ಒನ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? Electrophoresis. What we dealt this one in the last class, electrophoresis. So you know that in case of electrophoresis, what happens actually? The colloidal particles, or you can say the colloids, colloidal particles, that is the dispersed phase, will move towards the opposite electrodes depending upon their charge, and they will get deposited by discharging or by losing their charge. So if they lose the charge, they will settle down. Then we are going to get a coagulate or the precipitate. So what we can say, the electrodes, that is the colloids get deposited on opposite electrodes based on their charges, so that leads to what? Coagulation, or you can say the precipitation. It is one way to remove the charge of the colloidal particles, right? So they will get discharged or they will get deposited at the opposite electrodes, right? So next one, second method, if you have by mixing the colloids. So what is this mixing of colloid means? So here if you take a positive colloid and if you mix with a negative colloid, the charge will be get neutralized. And the solution what you are going to get will be a precipitate of that colloidal solution. It is a simple process where we are going to mix a positive colloid with a negative colloid. So which leads to what? Neutralization. You know this one, just like your acid and base, they will get neutralized. Likewise here, plus number of positive charges is equal to number of negative charges, then the solution will get neutralized. So that leads to what? Precipitation of that colloidal solution. So one example I can give for this one. If you take a ferric hydroxide salt, what is the charge of ferric hydroxide salt? It is positive colloid, right? So and if you mix with some say for example arsenic sulfide, which is having a negative charge, so then what the solution you are going to get? No, that will be a precipitate, because ferric hydroxide neutralizes arsenic sulfide, or you can say arsenic sulfide neutralizes the ferric hydroxide. So totally, so that leads to what? Loss of the charge, and the colloidal particles will get settled down, because if there are no charge means then how it will be a colloidal solution? We are removing the charges by this method. Okay, so third one, if you move on, so that is nothing but the boiling. Boiling is one more method. By using that, what we can coagulate or flocculate the colloid. Okay, so what happens actually here? So when you boil a colloidal solution, adsorbed layer get disturbed. Adsorbed layer get disturbed. Right. So you know that a colloid is formed because of the combination of two layers, that is nothing but a fixed layer and the mobile layer, right? The adsorbed layer means here it is nothing but a fixed layer. If that will get disturbed, what happens? So that leads to, if the layers get disturbed, then we are going to see there is a formation of, or there will be increased number of collisions. There will be increase in the number of collisions between the charged particles, that leads to again settling off. So it increases the collisions. Increases the collisions, right? Are you getting? So here increases the collisions and lead to what? Precipitation or settling down of the colloidal particles, because they are colliding with each other. Why they are colliding? Because you are boiling the substance, colloidal solution you are boiling, that's why. Okay now, so likewise, so if you take the water and the milk, if you continuously boil and if you leave for this one, so what happens if you allow it to cool? So it will be get what? Precipitated, right? Or you are going to see that there is a thick layer formation. Likewise, you can have the starch also. If you boil that one and if it allow it to cool, it will also settle down like that. So if you boil a colloidal solution, so it will be get converted into a precipitate. Like that, we can see that boiling, in case of boiling, the adsorbed layer get disturbed and there will be increased collision between the colloidal particles, that leads to the settling down of the particles, and then a colloidal solution will be converted into a precipitate. That is one more method for this one. Okay, so likewise we are having say for example one more method, that is by persistent dialysis, by one more process that is called as the persistent dialysis. We already discussed this one also, by dialysis, or you can say by persistent dialysis. So what is this dialysis? That is one of the process which is we are going to employ to remove the impurities present in case of the colloids. That impurities may be electrolytes. They are responsible for the stability of the colloids. We already discussed this one. There should be a traces or very small amount of colloids, that is electrolytes, should be there in the colloidal solution in order to maintain the neutrality, or we can say that in order to be the charge of the colloids, in order that solution to be colloidal solution, what should be there? So there should be some amount, that is trace amount of electrolyte should be present. But if you do persistent dialysis, what is the meaning of that? Prolonged dialysis, continuous dialysis. So what happens? It removes, persistent dialysis removes the traces of electrolytes also. Traces of what? Electrolytes also. Okay, traces of electrolytes, which leads to what? Which leads to settling of the colloidal particle, which leads to the as there are no electrolytes, so which leads to settling down of what? Colloidal particles, settling down of colloidal particles. So this is what happens when a continuous or a prolonged, or you can say a persistent dialysis if you do, almost all the amounts of electrolytes which are responsible for the charge of the colloid will be get removed off, and that leads to the settling down of the colloidal particles. Okay, so one more method what we can employ, that is very important here, that is the fifth one, by addition of or by adding electrolytes. by adding electrolytes. So I already told here, so that is electrolytes kya hai? So or you can say the electrolytes are there? No, they are trace amount are responsible for the charge of the colloid. But if you increase the concentration of those electrolytes, or if you increase the percentage of those electrolytes in the colloidal solution, so what happens? The oppositely charged electrolytes and the colloidal particles will attract each other, leads to the what? Precipitation, or you can say the flocculation of the colloid, right? Are you getting the concept? If they are in the trace amount, some colloidal particles will get the negatively charged or positively charged ions of the electrolytes, so they will get precipitated. But trace amount we have that is responsible, but remaining excess amount if you are taking means what happens? More number of anions, more number of cations will be there in case of that electrolytes, which will cause the precipitation of what? Our colloidal particles. Are you getting the concept here? So what we can say? Trace amount of electrolyte, trace amount of electrolyte is responsible for the stability of colloids, right? Stability of colloids. But if its concentration, or you can say the amount is increased, then the opposite charges of what? Colloidal particles and the electrolytes attract each other and leads to what? Precipitation, or you can say the flocculation, or you can say the coagulation of the colloid. So if the electrolyte is present in small amount or in traces, so that will cause what? That is the responsible for the stability of the colloidal particles. But if it is present in higher concentration or in large amount, what happens? The ions of the colloidal particles and as well as the what? Ions of this electrolytes will attract each other and leads to what? Precipitation, or you can say the flocculation, right? So these are all the different what we can say the methods which we are going to employ to convert a colloidal solution into a precipitation, or if these are the factors responsible for the coagulation or flocculation of a colloidal solution. Okay, what is that? So conversion of colloid to a precipitate by addition of some reagents or by some methods or suitable method. What are those suitable methods? It may be electrophoresis, I already discussed this one, by mixing of the oppositely charged colloids, or by boiling where the adsorbed layer get disturbed and leads to increase of collision, and finally the particles will get settled down, right? So one more point is the persistent dialysis. So in case of dialysis, the crystalloids, or you can say the electrolytes which are associated with the colloidal particles are removed by using the suitable membrane, that may be the parchment paper also. Okay, so there will be a dialysis bag through which the colloidal particles will not come out, but the electrolytes, because of their small size, will come out. So if you remove the almost all the electrolytes from that one, so that will cause the what? Settling down of the colloidal particles. Okay, likewise here in case of by the addition of electrolytes, in one place we are telling that electrolytes are responsible for the charge of the colloids, right, for the stability of the colloids. But here if they are present in excess, so what happens? So opposite charged electrolytes will get attract each other with the colloidal particles, so that leads to the precipitation. So based on this, the fifth one, we are having one concept. So what is that? Greater the valence of a flocculating. See here the ion which is responsible for the flocculation, is called as ಫ್ಲಾಕ್ಯುಲೇಟಿಂಗ್ ಅಯಾನ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾವು ಅದನ್ನು ಕರಿತೀವಿ, ಅಥವಾ ಪ್ರೆಸಿಪಿಟೇಟಿಂಗ್ ಅಯಾನ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಕರಿತಾ ಇದ್ದೀವಿ. ಸೊ ಅದರ ವೇಲೆನ್ಸಿ ಎಷ್ಟು ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಆಸ್ ದ ವೇಲೆನ್ಸಿ ಆಫ್ ದ ಫ್ಲಾಕ್ಯುಲೇಟಿಂಗ್ ಅಯಾನ್ ಇನ್ಕ್ರೀಸಸ್, as the valency of the flocculation ion increases, what happens, its flocculation power also increases, its precipitating ability also increases. So based on this we are having one rule, that rule is called as what, Hardy-Schulz rule. Okay, Hardy, so that is Schulz. Hardy-Schulz rule is there. What that say? So that says that the greater the valence of, so what is the statement for this one? The greater the valence of a flocculating ion, greater will be its flocculating ion, greater will be its flocculating power. Okay, so flocculating, or we can say that one as greater will be its flocculating, or greater will be its power to cause precipitation, greater will be its power to cause precipitation, right, precipitation, or you can say flocculation, or you can say coagulation. So higher the valency, greater will be the flocculating power. So in that sense we are having one concept. So there are some electrolytes, ions of the electrolytes, so which may cause the flocculation of a positive colloid, or that may cause the flocculation of a negative colloid, right? You should know that. So for the coagulation of a positive colloid, we are in requirement of a negative colloid, and vice versa. Let us have some example. We are having say we are having some sole like arsenic sulfide. We are having some sole, right? Example for this rule is arsenic sulfide. That what is the charge of arsenic sulfide? It is a negative sole. Okay, so the order of ions which are responsible, or the order of the electrolytes responsible for the coagulation of this negative sole will be in the form of, say we are having, say Al3 plus, that is aluminium, greater than Ba2 plus, greater than Na plus. So here you are going to get questions. Here you are going to get 1 marks question. Okay, so out of, say for example, aluminium sulfate and barium sulfate, which will cause which is having highest coagulating power, like that we can. So here Al3 plus, that is because of its greater valence. Higher the positive valence, higher will be its coagulating power to coagulate the negative colloid. Remember this one. Look at the charge. Al3 plus, it is Ba2 plus, it is Na plus, just only one valence. 2 valence, 3 valence. What is the rule is saying? Greater the valence of a flocculating ion, greater the valence of a flocculating ion, greater will be its power to cause, greater will be its power to cause precipitation. Are you getting this concept? So ಅದರ ಮೇಲೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಷ್ಟೇ ಅದು ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅನ್ನು ಬಹಳ ಸುಲಭವಾಗಿ ಕಾಸ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಅರ್ಥ. ಓಕೆನಾ? ಸೊ ಹಾಗಾದರೆ ಈಗ ನಮ್ಮ ಹತ್ರ ಒಂದು ನೆಗೆಟಿವ್ ಸೋಲ್ ಇದೆ, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ arsenic sulfide. So it will be precipitated by using these flocculating ion. This is the order. So which will come first in the race? Al3 plus. It will cause the precipitation of this arsenic sulfide more easily compared to these two. And if it is required in smaller quantity also, it will cause the what? Precipitation. It is having in larger quantity, it is in smaller quantity, but then also which will cause the what? Precipitation easily. So that is nothing but Al3 plus, that is according to the rule. right. So again, if you are having a that is a positive soul, like one more example, positive soul, like you are having a ferric hydroxide soul. For that ferric hydroxide soul, so what are all the we can take the flacculating ions, like that is ferrocyanide FeCN 6 times, that is 4 minus, that is having a greater valence compared to the PO4 3 minus, right, PO4 3 minus, that is having greater flagellating power than sulfate SO4 2 minus, that is having highest flagellating power or greater flagellating power than the chloride. So look at the charges here. So it is having a minus 4, okay, it is having, so that is minus 4, minus 3, minus 2, minus 1, or simply you can represent that one as minus, which is having highest valence, this one, right. So that is ferrocyanide, that is a coordination complex. So which is having highest coagulating power to cause the what? The flocculation or precipitation of this one. So if you take this one, that is PO4, it is having only what? Minus 3 charge. Right. So compared to this one, minus 4 and minus 6. See, don't look at the negative charges here. Number of negative charges is important. Higher the number of negative charges, more will be its precipitating power. Similarly, higher the number of positive charges, more will be its precipitating power. Okay, don't see that, oh, minus 4 is smaller than minus 3, don't look like that. Okay, you have to see more number of negative charges, more number of positive charges, more will be there what? Precipitating or coagulating power. So that is nothing but what? Our Hardy-Schulze rule. Understood this one? And one more thing is there here, that is flocculation value. Flocculation value, or we can say that one as coagulating value also. It is also called as coagulating value, or in some books we are going to give that one as flocculation number. So what is this actually? So that is nothing but the minimum concentration of an electrolyte, the minimum concentration of an electrolyte, minimum concentration of an electrolyte in millimoles, required to cause the precipitation of a sol in 2 hours. Precipitation of a sol in 2 hours. A sol in 2 hours is called as what? Flocculation value, or we can say that one as flocculation number. Flocculation number. Flocculation number, right? Sorry for the disturbance. So here, so flocculation, right, value, or you can say the coagulating value is defined as the minimum concentration of an electrolyte in millimoles. The concentration of electrolyte should be in millimoles, which is required to cause the precipitation of a solution in 2 hours is called as what? Flocculation value or coagulating value. Okay, lesser the value, more will be the what? Its flocculating power. Lesser the, note, you have to note down here, lesser the value, more will be the flocculating power. More will be the flocculating power. That means to say, if you take the Al3 plus and Ba2 plus, Al3 plus will have lesser coagulation number. So that's why it is having highest coagulating power. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳ್ತಿರೋದು? ಎಷ್ಟು ಫ್ಲಾಕ್ಯುಲೇಷನ್ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಷ್ಟೇ ಫ್ಲಾಕ್ಯುಲೇಷನ್ ಪವರ್ ಏನಾಗಿರುತ್ತೆ ಅಂದರೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಅರ್ಥ. ಹಾಗಾದರೆ ವಿಚ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಹೈಯರ್ ಚಾರ್ಜ್ ವಿಲ್ ಹ್ಯಾವ್ ಲೋಯರ್ ಫ್ಲಾಕ್ಯುಲೇಟಿಂಗ್ ವ್ಯಾಲ್ಯೂ, ದಟ್ಸ್ ವೈ ಹ್ಯಾವಿಂಗ್ highest flocculation power. Are you getting the concept now? Is that clear? Lesser the flocculation number or flocculating value, greater will be the valence and greater will be the what? Flocculation power. That is the concept. Okay, lesser and then greater. What is this lesser? Lesser the flocculation number, greater the valence, greater will be the coagulation power. Like that you can also remember. And I hope you understood. Lesser the flocculation number, greater the valence, greater will be the flocculating power. That is the concept. If they have given some values for the coagulation number of this is this much, this ion is this much, out of these two, which is having highest flocculating number, flocculating power, then you have to look at the values. The value which is smaller in magnitude, that will have the highest coagulating power. That concept you have to keep in your brains. Or else how you are going to get the question? They are going to give these salts of these ions or electrolytes of these ions, and they will tell you to compare the flocculation power. Then you have to see that. So first you dissociate them and look at the charge of them, and the one which is having highest charge will have the highest coagulating power. That also you have to keep in mind. And this is which rule? This is called as Hardy-Schulze rule. Okay, so this is all about the what properties of colloids. So last concept in case of this colloids is what that is called as the protection of the lyophobic colloids, or you can say that the protection of colloids. Okay, so for that you should know the stability, or you can say flocculation of lyophilic soles. So can we cause the flocculation of lyophilic soles? So because you know that the charge, or you can say the stability of these soles, are you getting the concept? Okay, are you getting here? The stability of these soles is due to these reasons. Is due to, one is its high degree of solvation, because it is lyophilic. It is lyophilic, that means to say it is having a higher affinity towards the solvent. Solvent loving it is. Okay, and one more point that is responsible for this is nothing but its charge. So this is we can give the higher number here, so which is responsible for the stability of this lyophilic sole. If any one of these two factors are removed, then we can see that coagulation of the lyophilic soles. So how we can do this one? Charge removal is by the addition of electrolytes, or we can do by adding an electrolyte we can remove the charge. And if you take this one solvation, in case of say for example hydrophilic soles, that is water is the dispersion medium, right? Or that is a dispersion medium, that is DM is nothing but the water. If you replace the water by means of some other solvents like your we can say acetonilide we can have, or we can have some alcohol, acetone or alcohol. If in case of what hydrophilic soles, so if the solvent is removed or exchanged with alcohol or acetone, or you can have acetone. Okay, water is replaced by alcohol or acetone, dehydration takes place. That leads to what? Settling down of the colloidal particles. If there is no medium, then what happens? Settling down of the particles takes place, that leads to the coagulation. How you can remove the charge of lyophilic soles? By adding an electrolyte. By adding electrolytes, what we can do? We can remove the charge totally. We can flocculate or we can coagulate what? The lyophilic salts. Right. So, and if you come to the lyophobic salts, so there is one concept there, protection of lyophobic salts. You know that lyophobic salts are highly unstable. Lyophobic salts are highly unstable, right, because they are charged, they are highly unstable. Lyophobic salts are highly unstable, so they should be protected by settling down. So how we can protect them? By without undergoing what flocculation or coagulation means. So by using what? By using lyophilic salt, which will form lyophilic salt. The lyophobic salts can be protected. That phenomenon, that process is called as what? Protection of lyophobic salts. As lyophobic salts are highly unstable, so if they covered by means of a lyophilic salt that is having high degree of solvation, so it protects the coagulation, or you can say the precipitation of the lyophobic salts. So we call that one as what? Protection of lyophobic salts. So we can have a suitable definition for that one. The phenomenon of preventing the coagulation of. So for this we are having the definition. For what we are having, so that is the protection of lyophobic, it is actually colloids or salt. So what actually it is? The phenomenon of protection of, or we can have the phenomenon of preventing the coagulation. The phenomenon of preventing the coagulation of a lyophobic salt. The phenomenon of preventing the precipitation, or you can say coagulation of a lyophobic salt due to the addition of lyophobic salt is called, is called what? Protection of what? Lyophobic salt. Protection of lyophobic salt. It is one more important concept. You have to note down this one. So that is lyophobic salt can be prevented by precipitation by the addition of what? Lyophilic salts, because they will form a sheath, protective sheath around the what? Lyophobic salt. Okay, so then this property of this lyophilic salts can be measured in terms of a number. That number is called as the gold number. So it is not there for your board. So gold number, what is this? This is the ability of what? Lyophilic salt to protect the lyophobic salt from the coagulation or the precipitation. Simply you can note out. So lesser the gold number, higher will be the protection. So there is a separate concept we are going to discuss in some other ways. So just for your theoretical concept, you should remember the flocculating, that is nothing but the protection power of lyophilic salt can be measured in terms of gold number. So lesser the gold number, higher will be its protection. Its protection mean here will be high will be protection. So it is in reference to what? Lyophilic souls. Lyophilic souls. Right? We can give the example. So here gold soul added to gelatin. Gold soul added to gelatin. Okay, so that is the concept with reference to this one. So finally we are having one more concept, that is nothing but the emulsions and applications of this colloids. So that we are going to deal in the next class. Okay, I hope you understood the concept. So just go through your NCERT textbook. All concepts has been clearly given. You read once, you are going to get the concept thorough. Okay, thank you.